This lesson introduces the importance of server monitoring. Often when we think of a server, we think about the application or service it's providing. It's a domain controller, it's an Exchange mail server, it's an IIS web server. But behind the scenes, there are a number of key resources that enable those services and applications to actually run. Those resources can really be broken down into four main components. So if I fire up Task Manager, and this is the new default you see in Windows 2012 and Windows 8, it's a very simplified view, but clicking more details actually gets us back to the view we're used to. We can see two of them. The CPU, the processor, and that processor is likely broken down into a number of processor sockets, i.e. physical processors, and then within that physical processor there's a number of processing cores. That may even be divided further if it supports hyperthreading, which allows a single CPU core to really run two instructions simultaneously. Then there's memory. So memory is physical RAM, but also it might be our page file configuration. So how much on disk storage do we use that may emulate memory when we need it? So the memory is very busy. We can page out, which means take pages from memory and write them to disk that are not frequently used. But also there's disk and there's network. And these are both critical resources. The number of IOPS or I/O operations per second and the network bandwidth we're actually utilizing. They're the four key resources we have in the environment. And I get a good view here. I can see my CPU. And here you can see I've actually got the graph set to logical processors. I could also see the overall utilization. And on this box, it has two NUMA nodes. I can see each NUMA node. A NUMA node is a non-uniform memory access. And it's the idea of when I have multiple physical sockets in a server, there's likely different banks of memory that are directly connected to a certain CPU socket. So the best performance is when processes run on a particular processor socket that's directly connected to a bank of memory. That's a NUMA node. So I have two NUMA nodes, and I have logically 16 processors. Now in reality, I have 8 processor cores. 4 on each of my physical sockets. I have 2 physical processors. But it supports hyperthreading, which is why we see double the number of logical processors. I have my memory. I can see the amount available. I can see the amount being used for caching. Now it's very important to understand available is not free. Notice we don't even see a free value anymore in Windows Server 2012. Free was just the amount of memory that wasn't being used at all. And people would panic because the free value would be very, very low. But why would it be? It's silly having memory that's just wasted. And so Windows will actually take any memory that's free and use it for caching. So you can see here I have 15 gigabytes used for caching, but my available is 20 gigabytes. So the reality is that 20 includes the 15 used for caching because if needed, it could dump out that memory used for caching and use it for applications. I can see, for example, my page file configuration. If I open up the control panel, fire up the system control panel applet, I can go to my advanced system settings. I can go to my settings performance. Under advanced, I can see my virtual memory. So right now, mine has actually been set to automatically sized, and it's currently using basically 14 gigabytes. Now actually, typically on a hypervisor, we wouldn't do this. We'd set it to a much lower value. So I can actually change that and customize where I want the page file to be and how big it should be. So that's memory. Now I have the disk throughput, the send and receive. I can open up Resource Monitor. This will actually expose more information. So it gives me a view of the CPU, the top users, and I can see that in Task Manager as well. I can go to details, I can order it by CPU, I can select what columns to view. And also under performance, I see an overall, and then processes, I see a heat map of who's using the most CPU and the most memory. On Windows 8, you'd also see network and disk here as well. So this is a Windows 8 box. So notice I can see my disk and my network heat map as well. The reason this isn't shown on Windows Server 2012 is the additional overhead of constantly collecting this information is not deemed worthwhile on a server. So back to my server, I'm going to go to Resource Monitor and I can see the CPU. I can see the details. Then I can go into the details of the CPU. service usage of resources, any associated handles for a given process I select. I can see my memory detail, how much is free, how much is standby. So notice here I do see free, so I've got this very small 5 gigabytes, which is the difference, remember, between my available was 20, standby 15, i.e. caching, and 5 is 20. So that's my available memory. I can see details of my disk. I can see my network. And what's really important here is you have to understand where your resources are being used and what is the bottleneck. So a bottleneck is what is slowing down a system. Generally, it's going to be either network, it's going to be disk, memory, or CPU. And there'll always be a bottleneck. Otherwise, things would finish instantly. And typically, your process will be, once you fix one bottleneck, maybe you are short on memory, it will expose another bottleneck. Maybe now it will be the processor, or maybe now it will be your disk I/O system. And you fix all those. Maybe now it's the network, or maybe the bottleneck becomes not even your machine. It becomes making requests to a domain controller or a SQL database. So now you have to troubleshoot that. It's not a problem having a bottleneck as long as the system is performing to your needs. So don't panic if maybe CPU is running high. It might be a CPU heavy application, but it's giving you the performance you need, in which case there's not a problem. It's only a problem if it's not meeting your requirements. Now what's very important is to make sure you baseline any new system. When you deploy a new server, run a baseline. This means see what its typical performance usage is of disk, of network, of CPU, of memory before you start loading it. And save that away. Understand what its base OS benchmark is. Then install your applications and your services, and then run another benchmark. Collect what it looks like now with that application running. Then over time, you can monitor, is it slowing down? Is it using more memory? Because sometimes services do slow down as more patches are applied, more things get installed on the system, things are uninstalled, things are installed, and gradually you get this junk on systems that does make it start to slow down. So by having a good benchmark of what the system originally performed at, that's a great place to go and actually compare later on. But certainly the Task Manager and Resource Monitor are two very good places to start when you do have performance problems and just start seeing, well, where are my resources actually going? So this completes the lesson on the importance of server monitoring.